Hello students, and welcome to the CompTIA Tech Plus exam course brought to you by Third Level Technology. I am your instructor, Jim Herbie. In this episode, we're going to continue in the exam objectives by discussing the final section of Module 4, Section 4.4, Organization and Logic. Let's begin.
We're going to begin our discussion by defining organization and logic, two key components of an effective computer program. Organization is the structured ordering of programming code. It is where we use the different methods of structure within a programming language to make sure that the code can be read as effective instructions for the computer. One example of organization is the use of tags in our markup languages. Hypertext Markup Language, HTML, a programming language that we use to create web pages. In HTML, we use a feature called tags. Tags are the way that we structure the different segments of code to make sure that we have a workable HTML web page file. Logic is the arrangement of our coding instructions in a determined order. It is the process of making sure that our coding instructions are followed in the proper sequence to make sure that the output that our program code creates is what was designed by the developer. You also want to be familiar with the term iteration. Iteration is a feature in our programming code where we repeat coding instructions. We will set a specific time length or numerical count to repeat a set of coding instructions. We call each cycle through those programming instructions an iteration. So now that we are familiar with those three terms, organization, logic, and iteration, we're going to now discuss some other features of our programming code related to these topics. Our next topic we're going to discuss is pseudocode. Pseudocode is a technique we use to create outlines of our computer code programming instructions. With pseudocode, we will use a text editor to create an outline of all of the different commands that will be contained within our code, as well as placing them in the proper sequential order. When using pseudocode, you want to make sure that each command begins with a commonly used term in your programming language. These would be commands such as start, print, add, enter, and others. These are common commands that we use within our code to perform a specific action. When you are using pseudocode, it's also a best practice to use indenting. Indenting is a technique we should use in our pseudocode to define any loops or conditionals that we will see within our program code. Loops are when we create an iteration or repeating of a specific code segment. Conditionals are when the user is given a choice to perform, and depending on the choice that a user chooses, the code will then move on to the next step in the command. Pseudocode does not require the use of formal syntax or punctuation. It is designed as a coding outline technique so that when we actually move on to creating our code within a specific programming language, we can easily translate over the commands that we created in our pseudocode outline. Next, we're going to discuss flowcharts. Flowcharts are graphical representations and displays of the algorithms and commands that we use within our computer code. Algorithms are processes and rule sets that we use in our code to perform calculations and to solve mathematical equations and operations. In a programming flowchart, you will see several common symbols. The first is a terminal symbol in the shape of an oval. The terminal symbol is used to indicate the start and the stop, or the end, of our computer code flow process. You will see one oval at the beginning and another at the end, and these will indicate the start and stop points of our code program. The second flowchart symbol to understand is input-output. Input-output is a symbol that uses the shape of a parallelogram. This is where a user will input data in the program, or we will have some type of output that is displayed on our screen. The third type of flowchart symbol is a decision. This is going to be in the shape of a diamond. Decisions are when we will have some type of true, false, or yes, no operation within our code. Typically, you will also see this in cases where you have some type of binary operation within the code. And the fourth symbol to understand are flow lines. These will be arrows that will move from one symbol to the next that will help us to determine the proper sequencing that occurs within our computer program. So we have terminal, input-output, decisions, and flow lines. Now in the second half of this episode, we're going to discuss the three basic structures that we use within our logical structure in our computer code. The three logical structures to understand are sequence, selection, and looping. Sequence is the main logical structure in our computer programs. It's a coding structure we use to put all of our different coding commands in a predetermined order. Within a code, you can have any number of commands, but you want to make sure that they are in the proper sequence. If we have any coding instructions that are skipped or that are in the improper order, this can cause our program to break. That means we will have no output created by the code. The second logical structure is selection. Selection is the logical structure that will ask questions within a program. Sometimes we also call these conditionals. Selection logic gives the user multiple choice options to choose or opt in the program code. The program will then process the input or the answer that is entered by the user and move on to the next step. One common selection technique is an if-else statement. This is a coding structure that will give a user multiple choices, and depending on the choice that is selected, will move on to the next step in our code. Another type of conditional is an if-then-else. This is where we need to perform an action in the code before we can move on to the next. And our third logical structure are loops. Loops are when we have some type of repetition within our coding instructions. We also mentioned that the term we use for this is iteration. Each time that we pass through or complete a programming loop, that repeating of those command instructions is called an iteration. We can identify the number of iterations by either numbers of repetitions or a specific time frame. There are three common looping structures. The first is a for loop. This is where we will use a counter to track the number of iterations or repetitions we do through a coding structure. The second type of loop is a do while. This is when our program will loop through a specific number of code commands as long as a condition is present or absent. And the third type of loop is a repeat loop. This is where we will continue to iterate or repeat as long as the value that is returned is true. You also want to be aware of nested loops. A nested loop is when we have an iteration or a coding loop inside of another. These are very easily recognized because nested loops will be indented within the program code.
That will conclude our discussion of Section 4.4, Organization and Logic, as well as conclude Module 4, Software Development. In our next episode, we'll move on to Module 5 in the objectives, Data and Databases, and discuss 5.1, Data Values. We thank you again for following along in the episodes and the course, and wish you best luck in your studies. Enjoy the rest of your day.